Hello guys, good afternoon again. Okay, welcome to physics laboratory class online. Okay, so today I will be doing the experiment number 5, which is the coefficient of linear expansion. Okay, the objective of the experiment is to measure the coefficient of linear expansion of some metals. So in this experiment, we'll be using 3 metal samples. Okay, so this is aluminum, copper, and brass. Okay, theoretically, when object is heated, okay, of course, the temperature of the object will increase. We will be expecting for the expansion of metal. Okay, so the change in length or area of volume of the metal is called thermal expansion. And thermal expansion can be linear, meaning yung length lang yung nag-expand, pwede ring wave. And then it can be also area expansion, in which the whole area, you need to consider the whole area. You just need to multiply the expanded length multiplied by the expanded wave. So that's the area expansion. And then it can be also volume expansion. Okay, but right now what I will do is only for linear expansion. So that will be in terms of the length of the metal rod. Okay, I am here 3 rods, pero i-demo ko ngayon is isang rod lang. Kasi you will be doing the same process naman for the 2 remaining rods. Okay, we will be using this setup. Okay, this is called the steam generator. Okay, so yung steam generator natin may water na sa loob. And then attached to the steam generator is a rubber tubing. The rubber tubing will be attached here. And then, so this is the linear expansion apparatus. Meron tayong gauge dito. Okay, so the purpose of this one is to measure the expansion, the elongation of metal. And then we have here the container. So ito lang yung magko-collect ng mga liquid. Okay? Kasi ang mangyayari, there will be changes in the phase of of the water. So from water, magiging vapor, steam siya, and then steam, then of course magiging convert ulit siya ng liquid. Okay, so ito yung kailangan natin para makulit yung mga liquid na yan. Okay, ang pinakamatagal actually ginagawa dito sa experiment na to is magpa-init ng water. Okay, so usually ang ginagawa ko is bago mag-start yung experiment, kinukuha ko ng steam generator, nilalagyan ko ng water, tapos pinapainit ko na siya. So para pagdating ng the actual class, madali na yung pagkuha ng result. Okay, kasi pinakamatagal talaga yung mag-produce ka ng steam. Okay, ang setup will be like this. Okay, I will be using brass. Okay, pero again, the first step is to measure the initial length of the metal rod. Yung length ng tatlong metal rods na to, magkakatulad lang naman. Okay, so this is 45.5 centimeters. Okay, so the LO. So this one, so here's the LO. So LO is equal to 45.5 centimeter. Okay, so yung mineasure ko kanina ay brass. Lagay ko lang dito yung mga specimen, brass, aluminum, tsaka copper. Pero again, ang sabi ko kanina, ang gagawin ko lang or i-demo ko lang yung para sa brass. Okay, so that's 45.5 centimeter. So mamaya, makikita natin kapag nag-apply tayo ng heat, dapat mag-expand siya. Okay, paano natin muli malalaman mag-expand siya? Makikita natin dito sa gauge na to. Okay, so i-set up ko lang siya. And then we also need to get the temperature. Kasi sa formula, sa pagkuha ng coefficient of linear expansion, the formula is delta L over LO or initial length multiplied by the change in temperature. So, gagamit tayo ng temperature sensor. Again, yung temperature sensor nakakonect naman siya sa DLX. And then, kailangan ito ay matouch niya yung metal rod. So, usually yung ginagawa namin, tinetake namin yung force sensor sa metal rod para sigurado na nakadikit talaga yung temperature sensor sa metal rod. So, ang kailangan ma-measure na temperature, yung temperature ng metal rod. hindi yung temperature ng environment, hindi yung temperature ng water, or yung temperature ng steam, kundi yung temperature ng metal rod. Okay, ilagay ko lang siya sa insulating foam. Like this. And then, i-set up ko na siya. This one, ganyan dapat yan. Okay. Actually, what will happen is, kapag nag-expand yung metal, pag nag-expand itong metal na yan, pag nag-expand siya, ipupush niya itong part ng linear expansion apparatus. Pag pinush niya yan, there will be rotation, counterclockwise rotation of the needle. Pag nag-rotate siya, meaning nag-expand yung metal. I-set ko lang to sa 0. Okay, so yan, nasa 0 na yan. Okay, so meaning mamaya pag uminit yung metal, yung expectation natin is mag-expand yung metal. Pag nag-expand yung metal, the reading will be here. Dito natin babasahin yung reading. Okay, again guys, whatever be the reading here, so that should be divided by 1,000. Okay, kasi yung bawat line dito, that is equivalent to 0.1 mm. Okay, so we need to convert that to 0.01 mm. And then we need to convert that to centimeter. So whatever be the reading here, divided by 1,000 to make it centimeter. Okay, kasi kanina, nung mineasure natin itong initial length ng metal, ang ginamit natin is in centimeter. So dapat yung reading dito sa gauge is also in centimeter. Okay, so I'll be connecting the tube here. Okay, so ano yung mangyayari? What will happen is the steam, i-on ko siya. Okay, what will happen is the steam produced by the steam generator will flow from the steam, pass through the rubber tubing, pass through the metal sample. Okay, and then of course, steam siya, mainit siya. The tendency is may iinitin yung metal sample. Pag uminit yung metal sample, there should be expansion of metal. Okay, so again, ang medyo challenge dito is yung hintayin natin na makapag-produce tayo ng steam. Pero kanina kasi, tinainitan ko na siya. Okay, so may initin naman yung water dito. So konting time na lang, makikita natin meron ng steam na lalabas dyan. And we just need to wait for the expansion. Again, yung expansion ng metal dito natin makikita. Okay, so the temperature can be read here. Okay, so ang gagawin ko is isaset ko siya sa minimum value. Okay, minimum value and maximum value. Okay, so the minimum value will be the value of the initial temperature of the metal sample, that's TO, and then the final temperature will be the TF, or the maximum value. So doon natin titingnan yung value niya. And then of course we have here the LF tsaka delta L. Yung delta L dito sa part na yan, okay, this one, ito sinasabi ko. The temperature, initial temperature, so this is the minimum value in the GLX. And then the TF, this is the maximum value in the GLX. Tapos the delta L is the reading in the gauge. Dito sa gauge na yan, ito yung delta L. Tapos yung LF, para makuha lang yung LF, you just add the LO at saka delta L. So the LF is simply LO plus delta L. Ito lang yan. So hintayin lang natin, siguro check natin dito sa gauge kung mag-expand na siya, and then at the same time i-monitor din natin yung temperature niya. Okay, and then after that, kung kumpleto na yung data natin, we will just use the formula para makompute natin yung experimental value ng coefficient of linear expansion. Yung theoretical value ng coefficient of linear expansion, pwede siyang makita dito sa appendix part. Coefficient of linear expansion. aluminum, copper, tsaka brass. Ito yung kakopihin lang natin yung mga values. Okay, for aluminum, so that's 23. Pag brass, 19. Pag copper, that's 17 times 10 to the negative 6. Okay, so this one is brass, aluminum, and copper. Yung theoretical volume ng brass, that is 19. 19 times 10 to the negative 6. 19 times 10 to the negative 6 per degree Celsius. Okay, so ito yung theoretical value. So ang kailangan natin mahanap yung experimental value. Again, yung target natin is to arrive on a 10% below percent error. Okay, hintayin lang natin. So pag nag-conduct kayo ng experiment na to, again, doble ingat lang kasi mainit yung steam. So may possibility na mapasok. And then yung pinaka-rubber tubing na to, as much as possible, huwag nyong ihaharap dun sa mga kasama nyo or sa classmate nyo kasi may tendency na lumabas doon yung mga may init ng water or yung steam mismo. Okay, ayun. So, tumataas na siya, nag-expand na, gumagalaw na. Okay. So, from 0, napunta sa 45, 46. And then, kung check natin ang temperature tumataas pa rin. So, ang gagawin ko is, mag-time ako. Okay, set ko ng 4 minutes. After 4 minutes, i-stop ko na yung reading dito sa GLX. Pero kung makikita nyo or mapapansin nyo, yung reading natin sa gauge, mukhang hindi na siya nagbabago. Nasa 46 pa rin siya. Pero i-check natin. Okay. So the temperature is 67.4, 68. Tumataas pa rin yung temperature. Pero yung ating elongation ay nasa 46 pa rin. Okay, so far nasa 39 seconds pa lang tayo. Hintayin natin maging 4 minutes. 79, 80 degrees Celsius. Yung expansion is nasa 46 pa rin. Mukhang hindi na nagbabago yung expansion niya. Okay, again, ang ginamit nating metal sample dito ay brass. So, iba't ibang metal, iba't iba yung kanyang coefficient of linear expansion. Okay, in temperature is 85.4.5. Tumataas pa rin yung temperature. Pero yung reading natin sa expansion ay 46 pa rin. 86.9, 87, 1 minute 45 seconds. degrees Celsius. Expansion is still 46. Hopefully, you can set your time. Siguro mga 3 minutes to 4 minutes. Minsan 3 minutes, hindi na talaga nagbabago yung reading ng temperature. Tapos hindi na rin nagbabago yung elongation. Pag nakita nyo nagbabago na or bumababa na yung volume ng elongation, meaning bumababa na rin yung temperature ng metal sample. Ganun lang naman. So the temperature of the metal is directly proportional to the expansion. Mas mainit, minsan mas nag-expand yung metal. Pero syempre may limit sila. Kaya nga kinukompute natin yung coefficient of linear expansion. Okay, yung expansion is 46 pa rin, pero nasa 3 minutes na rin tayo. And then the temperature is 89.9. Okay, so I believe pwede na nating stop. Okay, so hindi ko na hintayin yung 4 minutes, 3 minutes is okay. So i-stop ko na siya. Okay, so the minimum value here is 26.5. So initial temperature is 26.5 degrees Celsius. And then the final temperature, which is the maximum, so that's 90 degrees Celsius. Okay, so delta L is 46. Okay, that's 46 divided by 1000, so 0.046 centimeter. Okay, so for us to get the final length, so final length is simply the sum of 45.5 centimeter and the delta L. So that's equal to 45.546 centimeter. So change in temperature is the difference ng dalawa. Okay, final temperature minus the initial temperature. So that's 90 minus 26.5. Okay, so that is equal to 63.5. So change in temperature is 63.5 Celsius degree. Okay, may value na tayo ng theoretical coefficient of linear expansion. So ang gagawin ko is I'll be computing for the experimental. Okay, for the experimental value, ang formula natin is coefficient of linear expansion is the delta L over LO multiplied by delta T. Okay, yung delta L natin is 63.5. Okay, that is in centimeter, all over LO 45.5 centimeter multiplied by the change in temperature 63.5. Okay, so this is equal to, so we have 63.5 divided by 45.5 times 63.5. So hopefully, maliit lang yung percent error. Correction. So, mali lang yung naisulat ko. Delta L is 0.046. 0.046 centimeter. Okay? Ang nakopya ko is the change in temperature. Pero it should be change in length or expansion. So that's 0.046 centimeter. Okay, ulitin ko lang. So this is 0.046 divided by 45.5 times 63.5. So the answer is 1.59. So this is 1.59 times 10 to the negative 5. Okay? Per degree Celsius. So ito yung experimental value. So 1.59 times 10 to the negative 5 per degree Celsius. Okay. Yung 1.59 times 10 to the negative 5, that is the same with 15.9. 15.9 times 10 to the negative 6. So I compute yung percent error. So hopefully mababa siya. Okay, so that's 15.9. Tanggalin ko na yung exponential number times 10 to the negative 6. The same lang naman kahit hindi natin gamitin yun. So 15.9 minus 19 all over the theoretical value na 19. Okay, so times 100, medyo malaki yata yung error. Okay, the error is 16.32%. Okay, so this is for brass. So ang gagawin natin is papalitan lang natin yung up ko lang siya. Okay, so ang gagawin lang natin is papalitan lang natin itong metal sample. Okay, ilalagay natin yung ibang metal sample. The same process. And then ipoconnect natin dito yung temperature sensor. Then hintayin natin na mag-produce ng steam. Okay, and then immediate yung metal, and then hintayin natin yung expansion. Okay, and then again, i-record lang natin yung mga data. The same thing with the last metal na aluminum. So the same process, and then gamitin lang natin yung mga formula. So ang importante dito guys again is malaman natin yung volume expansion, and then kailangan natin malaman din yung mga change in temperature. Okay, and then yung target natin is as much as possible percent error is below 10. Pero usually sa experiment na to, we allow na yung percent error is mga 20%. Kasi may mga errors talaga dito nangyayari dito sa experiment na to. Okay? So, yun lang guys. So, we'll be sending the editable PDF for your group report. Okay, so i-fill out nyo lang yan, i-accomplish nyo lang yan, and then the submission of group report will be by group na siya, hindi na siya by pair. Okay, so again, let's pray na matapos na yung crisis na to, so pwede na tayo mag-experiment na hindi online. Okay, so see you guys. Bye-bye.